Hi everyone, I am Dr. P. Kumari, working as Associate Professor in Department of Mathematics, Institute of Aeronautical Engineering. Today in this video, I am going to discuss about the question bank of partial differential equations. So in our syllabus, we are having Module 3 partial differential equations. So here we are going to see about the question bank. So in the question bank already we know about this part A and part B and part C we are having. In part A we are having the problem solving and critical thinking questions. In part B we are going to have the long answer type questions. And part C we are having short answer type questions. So here what are the partial differential equations and how we can solve that partial differential equations and how we can form the partial differential equations already we discussed in the previous videos. So here first go through that previous videos about the partial differential equations. After then you can move for the question bank questions. Then it will be clear to you to solve the questions. So just I want to recall what are the topics we are having and how to solve these questions. So in the partial differential equations we are having first one is formation of PDE by eliminating arbitrary constants. This is the one topic. And again second topic is formation of PDE by eliminating arbitrary functions. So first one is the eliminating arbitrary constants and second one is the arbitrary functions and third one solutions of linear partial differential equation. So that is linear PDE. In solutions of linear PDE again we are having the two methods, that is one is method of grouping. And second one is method of multipliers. So here we are going to form the PDE first by eliminating arbitrary constants and arbitrary functions, and we are going to solve those equations by using the linear Lagrange's equation form by using the method of grouping and method of multipliers. So here what we done to eliminate the arbitrary constants, arbitrary functions means we are going to differentiate the given equation. And by using those two equations, we can form the PDE. After simplification, we can form the PDE. So, this is the procedure we are going to follow for forming of PDE. In the solution, we are having method of grouping and method of multipliers. So, what is the method of grouping? So, first of all, what is the linear Lagrange's equation? So, what is the form of the linear PDE? The equation form, we should have the small p and small q in the equation and there is no higher order partial derivatives. We should have only p and q and powers of p and q, small p and small q should be 1. Then we can get the linear PDE. So, here we are going to take the linear partial differential equation, that is Lagrange's linear partial differential equation. What is the form of the Lagrange's linear partial differential equation is capital P into small p plus capital Q into small q equal to R. So this is the equation form of the Lagrange's linear equation. So here to solve this equation we are going to use the method of grouping and method of multipliers. So how to solve? By using the method of grouping and method of multipliers. We can see here. So first we will write the auxiliary equation, that is dx by p equal to dy by q equal to dz by r. So after that, so we need to identify the p, q, r values from the given equation. After that we are going to take the set of equations. So here set of equations means here if you are taking this one as 1, this is 2 and this is 3. So for the given equation, what is the general equation or general solution of the given equation form is phi of u comma v is equal to 0. What is this u and what is this v? So u is the one solution and v is the second solution. So to get the final solution or general solution of the given equation, we need to get two solutions. So one is u equal to c1 and second one is v equal to c2. So after getting these two solutions, we can write the general solution. These two solutions should be independent. That is the condition you have to remember. So these two solutions should be independent. Then we can write the general solution for pi of u comma v equal to 0. So here to get this solution, we are following the method first, method of grouping. So in the method of grouping, we are taking the set of equations dx by p equal to dy by q, or dy by q equal to dz by r, or dx by p equal to dz by r. So we can get one solution from here, u equal to c1, one solution from the second one, that is v equal to c2. We can get one more solution, that is w equal to c3. So in this, we can get only two solutions. The two solutions are enough to write the general solution. In some of the equation, we can get three solutions also, but we need only two solutions. So we will take only two solutions. In some of the equations, we may get only two solutions. So that's why we have to check about the equations. Based on that, we have to select the set of equations. So coming to method of multipliers. So in the method of multipliers, up to writing the auxiliary equation is as it is. Up to writing the auxiliary equation is as it is. There is no change for the method of grouping also, method of multipliers also. After taking the auxiliary equation, we have to check about the set of equations are possible or not to get the solution by using the method of grouping. If possible to take the method of grouping, you will do that method only. Otherwise, we are going to move for multipliers. What is the condition for the multipliers? Otherwise, what is the procedure of the multipliers is, first we have to choose set of multipliers L, M, N. Three values. So, how we can say that these three are the multipliers means, here the one condition is there, that is L into P plus M into Q plus N into R. E should be 0. If it is 0, then we can decide that L, M, N are the multipliers. If this is becoming 0, then we can take the solution, that is L into dx plus M into dy plus N into dz is 0. So now integrating this, so L integral dx plus M integral dy plus N integral dz is equal to C1. So this one is Lx plus My plus Nz equal to C1. So like this is the solution. So in this way we can get the solution by using the method of multipliers. So here how we can choose the method of multipliers? What are the values we can choose here means, here that one important point you have to remember. So multiplier should not be a constant or variable. So we can take the constants also or variables also. For example, sometimes for the equation we can take the multipliers as xyz, and we can take 1, 1 also. Can take 1, 1, 0 also. Otherwise 1, minus 1, 0 also. And 1 by x, 1 by y, 1 by z. Or L, M, N. Or next one is 1 by x minus 1 by y and 1 by z. So sometimes x, z, y and x minus y, z. Like this, these are the examples of multipliers. So like this we can set, we can take the set of multipliers. So here variables are constant, need not be in the order. So what are the suitable to that equation? Based on that we have to select. So just we will move for the question bank questions here. See the first question here. Form the PDE, form the partial differential equation by eliminating the arbitrary function here. So here Lx plus My plus Nz is equal to pi of x square plus y square plus z square. This is the given equation. Here we have to eliminate the arbitrary function, that is pi. So first we are going to do the partial differentiation with respect to x. So L into, with respect to x we are doing, so x is 1 plus m into m and y, both are constants, so 0 plus n into dou z by dou x is equal to, pi differentiation is pi dash, so pi dash of x square plus y square plus z square into here, with respect to x we are doing, this value is 2x plus y square is 0 and z square also 0. So finally I am getting here L plus n into p. Dou z by dou x is already, we are having the notations in PDE, that is p equal to dou z by dou x and q equal to dou z by dou y and r equal to dou square z by dou x square and s equal to dou square z by dou x dou y and t equal to dou square z by dou y square. So these are the notations we are going to use in the PDE. So that's why I replace p here in place of dou z by dou x. So here this is equal to pi dash of x square plus y square plus z square into 2x. This is the equation 1. In the same way, we are going to do the partial differentiation with respect to x for the given equation. So here if you take this one as a 1, so this is 2. So now do the partial differentiation of equation 1 with respect to y. Before we done with respect to x, now we are doing with respect to y. So L and x both are constant, so first term is 0. Next, second one is m into y derivative is 1 plus here n into dou z by dou y is equal to, here pi derivative is pi dash of x square plus y square plus z square into, here derivative of x square is 0 because this is the constant and y square is 2y plus z square is 0. No. So here z is the function of f of x comma y. So that's why we don't treat z as the constant. So this one we have to write 2z into dou z by dou y. So here we wrote here 0, means here this value is wrong. So we have to write here 2z into dou z by dou x. So this becomes here 2x into 2x plus 2z into p here. So this is the equation 1. So equation 2, and here this one is m plus n into q. So dou z by dou q is q. So that is equal to pi dash of x square plus y square plus z square into 2y plus 2z into q. So this is the equation 3. So now I am going to simplify the second equation and third equation to get the PDE. So I am doing the division here, 2 divided by 3. So second equation is L plus NP by M plus NQ is equal to, so this one is pi dash of x square plus y square plus z square into, take the 2 common here, 2 into x plus zp by, this one is pi dash of x square plus y square plus z square into 2 into y plus zq. So pi dash will be cancelled here, 2 will be cancelled here. Finally L plus np by m plus nq is equal to x plus zp by y plus zq. X plus zp by y plus zq. Take the cross multiplication here, L plus np into, so y plus zq is equal to m plus nq into x plus zp. So now we are doing the simplification here to get the equation form of the PDE. So Ly plus zlq plus npy plus nz into pq. Like this you have to simplify this equation to get the PDE. So this is the way to eliminate the arbitrary function from the given equation. So in the same way for the second question also, here also we need to eliminate the arbitrary function, that is xy plus yz plus zx is equal to f of z by x plus y. So here also we have to do differentiation, partial differentiation with respect to x, and after then partial differentiation with respect to y, and then do the division here, second equation and third equation, then you get the PDE. So next coming to third one, here some different form is there, that is f of x square minus y square comma x square minus z square equal to 0. So from this we need to eliminate the arbitrary function. If they given the form like this, we have to remember the general solution form is pi of u comma v equal to 0 or f of u comma v equal to 0. If we are having the form like this, we can write this one as u equal to f of v. So what is the u value? U value is x square minus y square is equal to f of x square minus z square. So now this is the equation we have to take to differentiate and simplify. So first we are doing the partial differentiation with respect to x. Then this is 2x minus this y square is 0 equal to f value is f dash of x square minus z square. So x square is 2x minus z square is 2z into dou z by dou x. Now this value becomes 2x equal to f dash of x square minus z square, and take the 2 common here, x minus z into p. So in the same way, we can do the partial differentiation with respect to y, and we can simplify those two equations. Then we can simplify that to get the PDE. So problem to problem, it will be different for the simplification. Why? Because that depend on the given equation. So here this one and this one in the same way we can do. Here one more step we have to do. If it is given in the form of f of u comma v equal to 0, we have to write the form u equal to f of v. After then procedure is as it is. See the fourth one, that is z equal to f of x plus ct plus g of x minus ct. So here first we have to do with respect to x partial differentiation. So dou z by dou x equal to f dash of x plus ct into x value is 1 plus remaining two are constants, so 0 plus g dash into x minus ct into x value is 1 minus 0. So finally this is p equal to dou z by dou x is p, right? So this is equal to f dash of x plus ct plus g of here g of x minus ct. So in the same way we have to do the partial differentiation with respect to y also. So then we are going to get q equal to f dash of x plus ct with respect to y we are doing, right? So here x value is 0 plus here c in constant t also constant, but here we don't have the y, so we are having the t. That means we have to write with respect to t here. So this is dou z by dou t. So now x value is 0 and c is the constant and t value is 1. So here plus g derivative is d dash of x minus ct. So x value is 0 minus c into t derivative is 1. So finally c into f dash of x plus ct minus c into g dash of x minus ct. So like this we have to do the simplification. But here if you are able to solve these two equations to get the PDE, we can stop here. But here we don't get the equation PDE form by using these two equations. That's why we have to do the partial differentiation again. That means you have to do here 2 times partial differentiation and here 2 times partial differentiation. Then you can get the PDE form. See here. In the same way, fifth question also we are having, that is z equal to f of x plus iy plus g of x minus iy. So before we are having x and t, here x and y. So we can do partial differentiation with respect to x first, after then with respect to y. So we are going to solve these two equations to eliminate the arbitrary function from the given equation. See here, next sixth one we are having, solve the partial differential equation. So here they given here z square minus 2yz minus y square into p plus xy plus xz into q is equal to xy minus zx. So here we are going to solve this equation by using the grouping method also, method of grouping also and method of multipliers also. This will be depend on the given equation. When you are solving that, then you can identify the methods to solve the equation. So first of all, we are comparing with the Lagrange's equation, that is capital P into small p plus capital Q into small q equal to R. So here this is the P value and this is the Q value and this is the R value. Now we are writing the auxiliary equation, that is dx by P. What is the P value? Z square minus 2yz minus y square is equal to dy by xy plus xz is equal to dz by xy minus zx. Now here there is a possibility to solve the equation by using method of grouping. First we have to do that one. After then only we are moving for the method of multipliers. So here if you are observing the second and third terms, then we can get the solution from the method of grouping. That's why I am considering take second and third terms. So here when you are taking second and third terms, so this one is becomes dy by, take the x common here, x into y plus z is equal to dz by x into y minus z. So here x will be cancelled. So now we are doing the cross multiplication here to get the solution. So y minus z into dy is equal to y plus z into dz. Now y dy minus z dy is equal to y dz plus z dz. Now we have to write, take the all terms one side. So that is left side also, right side also you can take. Then it becomes y dz plus z dy plus z dz minus y dy equal to 0. Now integrate the function. So in place of y dz and z dy, I can write d of yz. Already we know this forms. Y or d of yz equal to y dz plus z dy. So you can write this form. So in place of this, I am writing d of y comma y into z. So plus integral z into dz minus integral y into dy equal to c1. So finally this is, when I am integrating the function, I am going to get yz plus z square by 2 minus y square by 2 equal to c1. So this is the first solution. So now we are going to get the second solution. How we can get the second solution? So here if there is a possibility to do the method of grouping again to get the second solution, we can do. But here there is no possibility to do the method of grouping. So that means we have to move for the method of multipliers for the second solution. So we have to choose the method of multipliers for the second solution. So choose multipliers as L equal to, M equal to and N equal to get the solution. Here just I am choosing the x, y, z. First I will check this. If it is becoming this value becoming 0, then I can decide that these are the multipliers. So first x into z square minus 2yz minus y square plus y into xy plus xz plus z into xy minus zx. So this is xz square minus 2xyz minus xy square. So plus xy square plus xyz plus xyz here minus z square x. So xz square minus xz square 2xyz here plus xy 2xyz here xy square we are getting 0. That means these are the multipliers. If this is 0, what we have to take? So here L into dx plus M into dy plus N into dz equal to 0. Oh, already we know this condition in the method of multipliers. If this is becoming 0, then we have to take L into dx plus M into dy plus n into dz is becoming 0. What is the L value? X. So x dx plus y dy plus z dz equal to 0. Now integrating the function, integral x dx plus integral y dy plus integral z dz equal to some constant. So this becomes x square by 2 plus y square by 2 plus z square by 2 equal to c2. The solution is x square plus y square plus z square equal to c1. This is the second solution. So already we got one solution from the method of grouping. Now this is from the method of multipliers. So for the seventh question, also here we can see p root x plus q root y equal to root z. So here we can compare with the auxiliary equation. We can compare with the Lagrange's linear equation. We are writing the auxiliary equation is dx by root x equal to dy by root y equal to dz by root z. So here we can get the solution, 3 solutions from the method of grouping. So that's why we can select any 2. So we can select 1 equal to 2 also. That means this is the 1, this is the 2 and this is the 3. We can take 1 equal to 2 or 2 equal to 3 or 1 equal to 3. So here we can get all solutions, that is v equal to c1, v equal to c2 and w equal to c3. So any 2 solutions we can consider to get the final general solution. So here also we are going to compare with the Lagrange's linear equation form, that is p plus p into q plus q equal to r. So we are writing the auxiliary equation dx by, here this value is 1 by x square, 1 by x square equal to dy by 1 by y square is equal to dz by z. That means this becomes p, q, r values. So we can do the integration here, dx by 1 by x square. First I am selecting 1 equal to 2, 1 equal to 2. So dy by 1 by y square. So when you are multiplying this, x square dx becomes y square dy. Now do the integration, integral x square dx equal to integral y square dy. This is x cube by 3 equal to y cube by 3 plus c1. So finally our solution is x cube minus y cube equal to c1. In the same way we can take the 2 equal to 3 to get the second solution, or 1 equal to 3. So then we can write the final solution, that is pi of u comma v equal to 0. So here also they given x into p plus y into q equal to 1. So here p value is x and q value is y and r value is 1. So now we are going to replace in the auxiliary equation. After then we can solve by using the method of grouping. Here 3 solutions are possible, that is dx by x equal to dy by y equal to dz by 1. So we can take 1 equal to 2 also, or 2 equal to 3 also, or 1 equal to 3 also to get the 2 solutions. Here also observe, see the 10th question. So we can take p value is y square z and q value is zx square and r value is xy square. So we are writing the auxiliary equation. So that is dx by p equal to dy by q equal to dz by r. So dx by p value is y square z, q value is zx square and r value is xy square. So now we can select the 1 equal to 2 also, 2 equal to 3 also, or 1 equal to 3 also to get the solutions. So finally we can write the general solution, pi of u comma v equal to 0. This is the first solution and this is the second solution. See the long answer type questions. Here in the first question they given form a PDE by eliminating arbitrary function. So here also they given in the same way the general solution, that is pi of u comma v equal to 0. So here u value is x square plus y square plus z square and v equal to z square minus 2xy. So you can write this one in the form of u equal to f of v. What is the u value? X square plus y square plus z square equal to f of v value is z square minus 2xy. So here what is the procedure we followed in the previous problem? Same procedure we are going to follow. First we are doing differentiate partially with respect to x with respect to x, and second one is differentiate partially with respect to y. So these two, after taking these two equations, we have to simplify the equation to get the PDE. So here also in the same way we have to do partial differentiation with respect to x and with respect to y, and here we are having x square by a square plus y square by b square plus z square by c square equal to 1 in the second problem. So we are having the power x square, y square and z square. So based on the problem we have to take, so here what we have to eliminate the arbitrary constants. So first step we have to do differentiate partial with respect to x, after then differentiate partial with respect to y, then simplify those equations to get the PDE. So otherwise there is no possibility to get the PDE. Again we have to do the partial differentiation with respect to x and with respect to y. After then we can simplify those equations, any equation with respect to x equation also or with respect to y equation also. See this one, form a PDE for the z equal to f of x plus e power y into g of x. First I am doing with respect to x partial differentiation. So dou z by dou x equal to f derivative is f dash of x and x derivative is 1 plus here u into v formula, e power y is the constant, so g derivative is g dash of x, x value is 1. So here next we have to do with respect to y, dou z by dou y equal to, so f is the function of x, right? So this is the constant plus here g of x is the constant, e power derivative is e power y and y value is 1. So this is e power y into g of x. So now here we are going to replace z equal to f dash of x plus, so here p equal to dou z by dou x is p, so f dash of x plus e power y into g dash of x, and here q equal to g of x into e power y. So in place of g of x into y I can replace the value to get the PDE form. Okay. So here we have to do one more step here by using these two equations. Otherwise the first derivative of equations we are not getting the PDE form. So that's why we need to do one more time partial differentiation with respect to x or with respect to y. So here dou square z by dou x square is equal to f derivative is f double dash of x plus here e power y into g derivative is g double dash of x. So here for the dou square z by dou y square equal to, here g of x is the constant, e power y into y derivative is 1. So in place of g of y into e power y we can replace the dou square z by dou y square. So when you are replacing that, so finally we can get the PDE form here. So find the partial differential equation or form the partial differential equation by eliminating the arbitrary function here. So here also do the partial differentiation with respect to x and after then with respect to y. Then here the equation 2 comes from the with respect to x and equation 3 comes from the differentiation of with respect to y. Then we can solve these two equations, that means doing the division. Then we can eliminate the arbitrary function, that is f dash of x square plus y square will be cancelled. Finally we can form a PDE from the equation which is in the 7th one. See here 2z equal to root x plus a plus root y minus a. So here also we have to do partial differentiation with respect to x, that is 2 into dou z by dou x equal to this is root x plus a. So that means root x is 1 by 2 root x, right? So based on that we have to do the partial differentiation with respect to x. So after then we have to do partial differentiation with respect to y. We are going to get two equations. We are going to solve these two equations to get the PDE form. So you can observe one more question here, that is xyz equal to f of x square plus y square plus z square. So here This is in the form of u equal to f of v. Here also what we discussed before problems in the part A. So we have to follow that procedure. First do the partial differentiation with respect to x and with respect to y. After then we are going to solve these two equations to get the PDE form. See the 11th problem. See here. Solve the partial differential equation. What is partial differential equation? Px square plus qy square equal to z into x plus y. So how to solve this question we are going to discuss now. So 11th one. So p into x square plus q into y square equal to z into x plus y. Here we are going to write the auxiliary equation. I am not writing all steps. Already we know this. So dx by p value, that is x square, equal to dy by y square is equal to dz by z into x plus y. So here I can use one set of equations or grouping method to get the first solution. So that's why first I am taking dx by x square equal to dy by y square. Now integrate dx by x square is equal to integral dy by y square. So integral 1 by x square is minus 1 by x is equal to integral 1 by y square is minus 1 by y plus c1. So finally this is minus 1 by x plus 1 by y is equal to c1. This is my first solution. So second solution I can use the multipliers also. Otherwise I am going to take one more fraction ratio here. That is equal to, I am taking here dx minus dy. I am taking here 1 comma minus 1 comma 0 as the multipliers to get the fraction. So dx minus dy by x square minus y square. Now I am taking these two equations to get the solution. So take last two equations. Two members I am taking here. So that is dz by z into x plus y is equal to, so dx minus dy by, here x a square minus b square form, so x plus y into x minus y. So that is, here x plus y will be cancelled. So dz by z equal to dx minus dy by x minus y. I can write this one as a dz by z equal to d of x minus y by x minus y. So now integrate. So dz by z equal to integral d of x minus y by x minus y. I can take this one as a log z equal to log of x minus y plus log c2. So finally I can write this one as a log of z by x minus y equal to log c2. So this solution is z by x minus y equal to c2. So this is the one solution and this is the one solution. I can write the final general solution here. So here also we can follow the same procedure to solve the partial differential equation by using the method of grouping or method of multipliers. And we can check about the 13th question, that is y square into p plus x square into q equal to x square y square z square. Here also we can write the auxiliary equation dx by y square equal to dy by x square equal to dz by x square y square z square. So now we can get the one solution from the method of grouping and second solution also we can get from the method of grouping. Then we can write the final general solution, that is phi of u comma v equal to 0. So here we can observe this p tan x plus q tan y equal to tan z. So now we are taking, this is the p value and this is the q value and this is the r value. So we can write dx by tan x equal to dy by tan y equal to dz by tan z. So now we can take 1 equal to 2 or 2 equal to 3. That means first set of equations are 2, second and third equations are 1 and third equations to get the solutions. See the 15th question here, x minus a into p plus y minus p into q plus c minus z into z equal to 0. So here we are going to get this is capital P into small p plus capital Q into small q equal to R from, we have to first write. After then we have to write the auxiliary equation dx by x minus a equal to dy by y minus b equal to dz by z minus c. Now we are having this one is a constant, means directly we can do the integration here to get the solution. So first take first set of equations 1 equal to 2 and 2 equal to 3 or 1 equal to 3 to get the solution. See the next one. So see here y square x square, this is px square plus qy square equal to z into x plus y. So we are going to write the auxiliary equation, that is dx by x square equal to dy by y square equal to dz by z into x plus y. So one solution you can get from the grouping method for the 1 equal to 2, and after then we can take the method of multipliers. So that means we have to select the multipliers to get the solution for the second one. So we can write the final central solution by using this. In the same way we can solve the 17th problem also, and we can observe here 18th one, that is y square z by x into p plus xz into q equal to y square. So here this one is the p value. So dx by y square z by x is equal to dy by xz equal to dz by y square. So first we have to take these two, and here if there is a possibility to simplify the equation, first simplify, after then check about the grouping method. So in grouping method, if you are getting or not, we have to check about the solution. If you are not getting, we have to use the multipliers method. So here also see the 19th question. Here there is no possibility to do the grouping method. We have to take the set of multipliers only. So for this we have to choose the set of multipliers as 1 by x and minus 1 by y and minus 1 by z. Then you can get L into P plus M into Q plus N into R should be 0. Then directly we can take L into dx plus m into dy plus n into dz equal to 0. Then we can integrate the function to get solution here. So this one also in the same way we have to use the multipliers method to get the solution. So this is the way to solve the problems, and I hope you understand these all problems about the question bank questions. So for more clarity and for the more examples, you can refer these textbooks. So Higher Engineering Mathematics written by B.S. Gravel, and a textbook of Engineering Mathematics written by N.P. Bali and Manish Goyal, and Higher Engineering Mathematics written by B.V. Ramana, and one more textbook is there, that is Engineering Mathematics written by T.K.V. Iyengar. And these are all textbooks you can refer for the solutions and more examples. Then it will be clear to you about the solutions of partial differential equation. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.